one, we're going to find the maximum and minimum values for y equals 2 sine squared of x plus pi sine of x plus pi divided by 2 minus 1. All right, so the first thing we're going to do is rewrite this using our reference angles. So if we had sine of x plus pi, or that would be the same as pi plus x, so that's 180 plus my angle, that equals negative sine of x. Since ours is squared, let's square both sides. So this is going to give me sine squared of x. Now for this piece here, this is going to be sine of x plus pi divided by 2. So that's 90 plus theta. That gives me cosine. So I'm going to substitute these back in my original equation and get y equals 2 sine squared of x plus cosine of x minus 1, equivalent expressions. Now what we're going to do is let cosine of x equal big X. And therefore my big X has to be in between negative 1 and 1 for your range. Now, when that's the case, let's substitute in for the x. So we're going to get y equals 2. We first have to, let's fix this. We have a linear term in cosine of x. So sine squared of x, we want to write that in terms of cosine. So using my Pythagorean identities, I'm going to write it like that. And then simplifying this is going to give me equals negative 2 cosine squared of x. Then we have plus cosine of x. Then we have 2 minus 1. So that's going to be plus 1. Now let's go ahead and substitute in our big X. So everywhere there's a cosine, we're going to put big X. Now we have y equals negative 2 times big X squared plus big X plus 1. All right, now what we're going to do is simplify this and look at that. So basically we have y equals negative 2 x squared plus x plus 1. What I'm going to do is complete the square so I can find the vertex because we can't factor this. So I'm going to write y minus 1 equals, and then I just have this piece. So I'm going to factor out a negative 2, and that's going to give me big X squared plus, this will be 1/2 big X. Now to complete the square, you take half of, this should have been a 2. You take half of 1/2, and that gives you 1/4, and you square it. So that's going to be plus 1/16. All right. And then so you're going to have to multiply this. This gives you negative 1/8. So since we're adding 1/8 to the right-hand side, or we're subtracting it actually, you have to subtract it from this side. Now, this is a perfect square trinomial. This is going to be negative 9/8. So we're going to write this as y equals negative 2, and you take half of 1/2, so that's going to be x plus 1/4 squared, and let's add this 9/8 to both sides. Okay, so that's the long way to do that. All right, now that we have that, what we want to test is, remember we had x is in between negative 1 and 1. So we're going to test when x is negative 1 and substitute in negative 1 in here. You're going to get y equals negative 2 times negative 1 plus 1/4 squared plus 9/8. And this is going to equal negative 2. We also have to test y equals 1, or x equals 1. Sorry about that. So when x is 1, big X is 1, we're going to get y equals negative 2, 1 plus 1/4 squared plus 9/8. And that's going to equal 0. All right, and I'm going to go ahead and look at these two and the graph. So I went ahead and sketched a little bit of a graph. We have our equation is y equals negative 2 times big X minus 1/4 squared plus 9/8. That means our vertex is going to be 1/4, 9/8. That happens right here. And this is just a sketch, so I already wrote that. All right. Now so that's going to be your maximum. Now, the other 2 points we had this point when x was negative 1, we had negative 2. And when x was 1, our y was 0. So basically, this is your maximum here. So your maximum is 9/8 when x is 1/4. And your minimum is going to be here at negative 2, and that's when x is negative 1. Thank you. Have a nice day. Bye-bye.